Good day, everyone. My name is Brian Cruz, and I'm mentored by Jim Pivarsky. As the title suggests, my IRIS-HEP project is to translate an analysis into a prototype analysis system. More specifically, is to translate the CMS Open Data Higgs to 4-lepton analysis example from its C++ code to Python code that uses coffee and aqua array. The 4-lepton decays that I will show and perform the analysis is the 4-muons decay, 4 electrons, and 2 muons, 2 electrons. Additionally, I will compare the prototype and original analysis system, time of insight, functionality, and reusability. To show that the translation is working, I will show my results for the Higgs mass histogram, shown in red in this plot on the right, for all the decay process that I mentioned. To do this, I need to download the Higgs to 4-lepton AUD sim from the CMS Open Data portal. And I will do this on a Docker container. So I created this Docker container from the CMS software 5332 image and mounted a shared folder to share this, the nano AOD that I will produce from the AOD sim mentioned in the previous slide. I additionally downloaded 2 GitHub repositories. The first one, it contains the ED analyzer, the original code that I will translate. And the second one contains a code to produce the n-tuples for which I will perform the analysis on, since the original only gives the histograms as the output and no analysis can be done by code. So I input this this AOD sim file to a the Python configuration file of the outreach tool. I call both ED analyzers to be run with this input, and then run the configuration file to produce the nano AOD and move it to my share folder so I can then finally perform the analysis. I used Jupyter Lab to perform this analysis. I will show a few C++ code just for comparison, but mostly show the translated Python code, which I'll try to keep on the right side of the screen for consistency. I will have as I mentioned, the 3-4 decay process. And yeah. You need to move it? Oh, sorry, give me a second. Right, sorry. So the next part is part of the code in Python that the first thing to do is to call the events T tree from the the n-tuple that I produced. Call the muon branch and perform a slice to have the good muons of this muon branch. And then I will make sure I select the entries that have 4 or more muons and sort them by highest to lowest transverse momentum. Then I make sure I select the first 4 muons out of each of the entries in the array and make sure that the total, the net charge of these 4 muons is 0, as they come from the Z boson and the Higgs, which are neutral, which contain a neutral charge. For this 4 muons, I use AK combinations to consider all the unique combinations out of these 4 muons. And with these combinations, I look to obtain the closest and the farthest Z boson mass from these pairs. And after flattening this array, so I have a more simple array, I can perform mass cuts and transverse momentum cuts of the Z boson to then obtain the good Z bosons and perform the sum of the closest and farthest Z bosons to finally obtain the Higgs array and perform a mass slice. And finally, to that Higgs array, I can plot. So in this plot here, I show together the outreach tool, the translated, and the original Higgs. The original is in red and the translated is in blue. And as we can see from this plot, the histograms are rather identical. So the translation is working. So on the other hand, for the decay to 4 electrons, the only differences in the code is just selecting the electron branch, and making sure you select the good electrons. The rest of the code remains the same. And as we can see from the plot, there are a few bins, few of the peaks that overlap. Again, the blue is the translated. So there are a few more events appearing compared to the original in red. The best guess I have of why this is that the translated, the outreach tool is not performing some of the cuts that the original code did. So when we perform this this analysis for the electrons, a lot more electrons events appear from the translation. And finally, for the Higgs to 2 muons to electron decay, much of the code remains the same, the essence of it. The only major difference is that we don't need to consider combinations as we did for the 4 muons and 4 electrons. As in the Higgs will decay to 2 Z boson, and 1 Z boson will decay to the pair of muons and the other for the pair of electrons. The rest is just the same. You still need to consider the closest and the farthest Z boson mass, and from that get the good Z bosons, perform the sum, and get the Higgs just as before. And as we can see, the plot is rather identical, but it shows also right at the left side, there's a bit of a blue overlapping with the red. So I considering, since now we have the electrons and the muons together, the same issue from the 4 electrons is carrying over to this decay. So there are events that are not cutting for the electrons. And finally, I have about a week more of work, and what I will like to do is make the Python code scriptable. So I have 3 different Jupyter notebooks for each of the decays. So I would like to have them together and produce the plots, but save them in your local computer if you want to run the code. And I've been trying to understand how to run a Kubernetes cluster in Google Cloud to scale up the nano AOD production. So I showed early on in the presentation that I only took 1 AOD sim, 1 Higgs analysis sample out of the open data portal. And so there are 20 more samples, but I will need a powerful computing to be able to run the analysis, to produce the nano AODs and then run the analysis on those samples. with the hope to then produce the Higgs plot, the first one I showed in the presentation that contains not just the Higgs mass, but the Z to 4 leptons and the other plots as well. And with that, I am done with the presentation. Any questions?
Thank you, Brian. Any questions for Brian? Going once? No? Okay. Thank you, Brian, for your presentation, and
Thank you.
Thank you, Jim, for your mentorship.
So my name is Zora. I go to Boston University. I'm a CS student there, and I'm a rising senior. So I've been working with Oksana for the last 5 months on Coffee-Casa, and I've also been working on a feature for IRIS-X. So I'll be going through my work for the past 2 quarters. I'm listing my fellowship goals here to kind of frame my discussion. So I would categorize my main objective is to be one of the first users of Coffee-Casa to kind of give suggestions towards improving its current functionalities. And also I've been adapting different kind of analysis code into onto the platform. And kind of the last bullet point talks about integrating with Skyhook DM, which in my actual project, I'm using the Skyhook persistent volume to kind of test out a new feature for IRIS-X, which I'll go more in detail. So the first things I started with for this fellowship is to adapt one of the analysis from the Boston University group for Coffee-Casa. So this is analysis is fake rates analysis. So here we're interested in analyzing the fake rates to kind of tune the background for just better analyze of signal. So for me, as someone who has kind of limited particle physics knowledge, I was able to produce a script which kind of speaks to the ease to use for coffee and also just the usability of Coffee-Casa in general. So for my process of turning this into like originally C++ code into the Coffee-Casa notebook, it was very it turns out to be productive for me to understand a bit about the bigger picture physics question, and for someone with physics background, Caitlin from the BU group to create slides for me for kind of the steps of the analysis, so I can write the corresponding code. And the only kind of the real difficulty I had was more related to kind of plotting based on the kind of difference between the coffee histogram library and the original root library, since some of the functions such as like dividing 2D histograms is not available currently in coffee. Oh, sorry, I wanted to share my like Google Doc too, so I will. So in case anyone wanna look at the links. So this is the slides that I started sending in the chat. Yeah, so here's kind of like what I got and what the original kind of root-based analysis histogram looked like. So, and there are grad students from the group to pick up my current work to kind of add more sophisticated cuts. And the goal is now we can use kind of what we get right now to test on the signal region. And additionally, we kind of did some performance benchmarking to analyze the processing rates for this current analysis and investigate some of the discrepancy or unexpected rates that we were seeing. So some of the discrepancy we saw was that for me sorry. Yeah, so for me, there were 722 million events and 74 gigabytes read, and it turned out to be lower kind of than expected, considering that we have access to a larger cluster, and we should have accelerated results. But as talking with the postdoc from BU, it was not as fast as the fastest C++ looper they had, although they were using these local files. So on here you can also see the two graphs corresponding with the events per second, with scaling number of workers, and also per thread. So I also would recommend looking at Matt's slides here, because they did more analysis on this part. But we were also wondering if the number of threads affected the efficiency. And also kind of the issue was a lot of the files were hard to open. And so on Coffee-Casa, it was stuck in opening. So it's stuck in the IO instead of moving to processing. So that kind of contribute to a lot of the time I would run analysis, but it will reach around 90% very fast, but spend a couple hours on the last 10% or even 5%. So we turned on the coffee skip bad files later, but we were also wondering if there's kind of more better ways to deal with this issue. Yeah, and here is you can see the for someone, I'm not sure if everyone's familiar with Coffee-Casa, but here are kind of the interface. You can see also the task report of the task stream. Yeah, so here are kind of more notes I had on this project. So again, kind of plotting differences is something that took a bit of time, and it could be dependent on the specific analysis, because they use the 2D ratio. And another thing that kind of physicists I was working with suggested was that it would be convenient to add the Dasco client kind of feature to be able to access on Coffee-Casa. So this essentially can search for root files, and it will speed up the process if we can implement it. So this would, so currently you can use a valid certificate on terminal and do the proxy initiation. On Coffee-Casa, we use tokens instead. So, but this should be something that can be implemented, and that would help the general analysis workflow. Another analysis that I started with was the Top Coffee repository. So this was already based in Coffee. So what I did was I adapted the command line input of chosen configuration into a function in the notebook. So I can generate a dictionary and pull up the specific configuration file. So I also had some slight issue with plotting. And we added like a more simpler plotting script. And this kind of raises an interesting point of how we can install users custom package for desk workers. Currently, we're using a dependency installer and also exploring other ways to make this more compact. And I want to talk about kind of in detail my last part of the project, which was adding a feature for Service X. So Service X is a service delivering data from the grid to these analysts. So it can be delivered in Coffee-Casa notebook format, or you can also go to the website and kind of submit a query in itself. So the goal is for it to be as user-friendly as possible. You can get your files in like a desired format. And here I'm adding a schema for people who are interested in the general Service X application. For me, I was working specifically on more on DevOps and in terms of like where data is written. So there's an open issue of writing transformer results to persistent volume. For the Service X application, currently there's no option to write to persistent volume, but there's the option of object storage. So here, I want to go through this kind of quickly because I don't want, I have around 4 minutes. But this is the story. So you can provide existing claim, storage class, size, annotation, and subdirectory. And the goal is if there is no given claim and you choose volume, a dynamically generated claim will be like generated via the provided storage class, and then it will be bounded to the existing PV in this case. And in my developing instance, I was using the Skyhook PV instead. And if there's existing claim, the claim will just, if it's valid, it will bind to the existing PV. So there are 4 directories that I was working with, and I have the corresponding PR. So the Service X, which is kind of also have description for deployment. The way they interact with each other is that the Service X repository is installed via Helm chart in my development space, and the Service X app is deployed by the Helm chart, and it can start the Service X uproot transformer pod using the image that I pushed to Docker Hub, and Service X app also is an image on Docker Hub that I pushed. And this is Service X transformer is base transformer that uproot transformer uses. So some major changes in Service X is to use config map for adding the new values, and also I changed the row configuration because in the app that I have, I need to allow the specific namespace I was using to create new persistent volume claim. And also some other configuration fixes to allow the new options. And this, I installed a local Helm chart that I modified from the official release. And majority of the changes is in Service X app, where in Transformation Manager, again, I'm following the logic given in the issue, generating PVC when there is none, and using the PVC when there is one. And I pass the subdirectory to the uproot transformer for writing results. And again, I'm using my custom image at Docker Hub. And I added some new parsing options. And for my specific image for uproot transformer, I have not very elegant solution currently, just because the Service X transformer is usually imported as a library. So for me, temporarily, I'm importing a local folder instead of the library itself, which could be changed after the base transformer is the PR is merged. And I also updated the output path. So currently I have transformer pods started and running for both cases with valid claim and no claim. I am having some issue finding a good QSO query and a corresponding file for me to test if it's written to the correct place. But if that is done, I will be finished with the issue. And so I've been developing on UNL Envil, and I've been also working my own namespace on CMS AF. So this project I've been kind of understanding Kubernetes and Helm interaction, also just debugging details such as like config map, like needing to delete it after, and do Helm upgrade again to update it. And also just finding a debugging friendly environment. Thank you to Ben Oksana, who helped me set up Postman on CMS AF so I can kind of deploy my application and submit a script directly. Yeah, so just want to say a huge thank you for everyone who has helped me during this process, especially Oksana, Ben, and Matt. And Oksana has been a wonderful mentor and being extremely supportive. Thank you for just making this a very enjoyable fellowship. And I'll take any questions if there's any.
I will just add a tiny comment. Thank you, Zora, for being my fellow. It was an amazing journey with you. I really enjoyed.
Yeah, thank you. You are truly amazing.
Any questions for Zora?
Hi, this is Kevin. I could ask one
Hello.
quickly. So as somebody that uses the Top Coffee code, I'm just curious if you'd be willing to say anything more about the dependency issue that you mentioned.
So kind of Coffee-Casa is set up there. So in order for the processor to have the package, right now we're like installing the package itself, like passing it to the worker. Sorry, I guess.
Yeah, I will just add a tiny comment because I think it was an initial task of Zora, which was like 5 months ago. So we opened PR with a notebook, which we were able to run on Coffee-Casa. But then in the moment, I think the problem is that Top Coffee is in very intense development phase. So we kind of the rebasing procedure of notebook through the code was kind of delayed. It took a bit of time. So literally what was interesting for Top Coffee is that it was our first notebook that had a Top Coffee package that we should install on both desk workers and the scheduler. And since it was not released in PEEP or something, Zora was working together with Matt on some kind of way how we can do this easily and install probably like local installation of this package. Yeah, so I would really like maybe to come back to this PR and discuss if we could merge it or if it is something interesting for you, Kevin.
Yeah, sure. Thanks. I was just curious what it was. So you're saying it's the fact that there's a package that needs to be installed. That makes it...
Yeah, it was not. It's actually very good because we were trying like to collect the set of the different analyses which are requiring different approach on Coffee-Casa. So, for example, Top Coffee is particular because it has by itself Top Coffee package that should be installed. And then also the other issue was that it didn't have notebooks. So we're kind of thinking about to have like also feature when you don't want to use directly notebook, but you just want to connect to the scheduler. So hopefully we will come back through this PR with a more interesting features for you. So you could try it on Coffee-Casa as well.
Yeah, that's great to hear. Thanks.
Anyone else? No?
I'll say very interesting talks. Caught the end of Brian's and Zora, and then all of Zora's. They're both very interesting fellowships, and thank you for participating.
Thank you.
Thank you. Thank you.
Right.
Okay. Any other questions or comments? No? Okay. Thank you, Zora, for participating in the fellowship and for giving this talk today. Thank you, Oksana, for your mentorship. that's it for today. So thank you all for coming. There'll be some more coming up soon later this month. So thank you.